Hello, this is Indu, and as I mentioned earlier, I'm a faculty in the Department of Civil Engineering at IIT Bombay. And in this talk, I would like to summarize our journey of being in the SWOT world for the last 7 years. So we know that floods are increasing in severity, duration, and frequency. And especially in India, urbanization is dramatically transforming the land both vertically as well as spatially, which means there is some changes happening in the large scale forcing, which in turn changes the spatial and temporal patterns of precipitation. And as such, an accurate real-time flood forecasting system is the need of the hour. But then we also know that discharge is not directly measured from space. It has to be estimated from measurable quantities. Now, the researchers have spent a lot of efforts through hydrodynamic and hydrologic modeling to aid in flood forecasting studies. But we also know that the fundamental laws of physics, that is mass conservation and momentum conservation, needs to be applied to allow discharge to be related to the river variables and parameters, which is input to these hydrodynamic and hydrologic models are a suite of measurements, one of which that the SWOT gives is indispensable for this talk. So this talk is divided quickly into two parts. One that is before the launch of SWOT mission, that is pre-2022, and one after the launch. So of course, now we know that SWOT can give us node averaged products, that is average water surface elevation at predefined nodes at 200-meter intervals along the river center line. And then we also get a reach averaged product stored in the SWOT database. And we know that unlike traditional satellites, SWOT can measure water surface elevation and inundation areas simultaneously, which is unprecedented from a single sensor. Now, in Asia, one of the regions that is most exposed to flooding and which is actually underrepresented in the global flood database is India. And so, as I mentioned earlier, we started the efforts in year 2018 when we wanted to actually use the SWOT data for flood related studies. But then because the satellite was not launched, we were not aware how the data looked like, let alone use it for modeling. So our first effort was to identify a study site which we know will have overpasses from the SWOT satellite during the calibration validation phase. Here you can see a particular location of Mahanadi River Basin in northeastern part of India. And the small dots you see are the gauging sites from the Central Water Commission. Now, across India, the Central Water Commission is known to be the primary authority for river discharge monitoring and data availability. And we had chosen the Mahanadi River Basin for our initial studies. But as I said earlier, we did not know how SWOT data would look like. Okay. So that's when we were trying to understand what are the inputs required for artificially creating SWOT data proxies. So thanks to the CNES large-scale hydrology simulator, we understood that we need to follow a certain number of steps to generate proxy SWOT data, which can then be used for understanding its applicability in Indian hydrology. So through these efforts, we also created an open source web application that Cassandra mentioned for automated mapping of temporal variation of inland water extents using Sentinel-1 synthetic aperture radar imagery, which went as input in simulating the proxy data. And our first efforts was to look at the SWOT derived reservoir bathymetry and to compare it with the actual in situ observations just to understand the range of error with which SWOT will provide the water surface elevation. Moving on, as Cassandra mentioned, that the actual data by now we understood that it's going to be looking like a point cloud, which is very dense And we cannot directly use it in hydrological modeling because the data itself is very heavy. Now, in situ measurements, we know, are the backbone of the current understanding of global surface water dynamics. So, in our initial study, we tried to evaluate whether SWOT mission will be useful to extend the measurements of water surface elevations from a sparsely distributed in situ gauge network extending along a 1D study reach in the same river basin, that is Mahanadi River Basin. And by now, we were also getting concerned about the temporal revisit time of SWOT mission. So we wanted to see, taking the case study of Brahmaputra, at what is the level or how SWOT data can help in creating something known as a flood severity zone. So that was one area we wanted to understand. And moving on, in the pre-launch phase, mainly when we look at capacity building, we understood that soon after launch, the mission is going to follow certain passes, SWOT, that also covered a few prominent large lakes in India. So, in collaboration with Faisal and of course Vivek from CWRDM, which is a state level agency in Kerala, we tried to set up gauges in the lake so that citizens also can join, be a scientist, measure the level, and then a message to a phone number, which can then appear as a time series. So this is part of the LOCSS in which I played a very small role to set up the site. And this actually happened during the pandemic when we were all stuck in our homes. And another effort which we conducted was, as the lead contact from India, we were involved in the GDRI SUD project, which stands for International Scientific Coordination Network South, where different countries had come together to identify what was called as the gold sites, that is within the calibration validation orbit of the SWOT mission. Okay. Now I'll move to the post-launch studies, that is after December 2022. When we actually started getting the real SWOT data, there was no longer any need for us to use the proxy data. Now, here you can see from the actual SWOT data for a specific period of time over India, we were trying to estimate the error in water surface elevation by comparing it with the in situ gauges of Central Water Commission. So this is an ongoing work. Plus, we have an ongoing work known as floods on Indian rivers through discharge estimation of SWOT data by looking at one of the rivers on the western part of India, that is Tapi. In this work, we are mainly trying to look at how coastal dynamics also contribute to the flooding. And this is in collaboration with our colleagues at IIT Bombay plus the team from France. Moving on. We know that river discharge estimation as such is highly crucial for various applications, but the measurement process often is hindered by several factors, one of which is the non-availability of near real-time data over India. Now, in this particular study, the near real-time water surface elevation from Central Water Commission flood portal is obtained using the web scraping tool. And then through the application of rating curves, we were trying to extend the discharge data across 210 gauging sites in India. And this is a work which will be released soon. Just to summarize our efforts, when we started our work, we were part of the SWOT early adopter projects, two of them with Faisal. And then slowly we moved to understand its effect in the international domain by collaborating with France, scientists from Germany and France. And we Could also now one of the ongoing works which I couldn't mention in detail due to paucity of time is how SWOT data can help in understanding the health of lakes by estimating the volume of water in lakes, which is also an ongoing work. So as part of the training efforts from our group, we have been involved in several capacity building efforts and training sessions conducted in India, as well as both through virtual sessions connecting researchers from all across the globe. And we had also presented our efforts at California during the SWOT launch, which was phenomenal. And finally, I would like to acknowledge the entire team of excellent collaborators and students who contribute this work. Because the work of such a massive scale cannot be done single-handedly. And we also thank the ISRO and NDMA for making available a lot of literature for us to understand the ground reality and then move forward from there. And these are my students, whom I thank profusely for making all ambitious works possible. And in case you have any queries, I'll be more than happy to attend. I've just added my email ID here. So I stop here. Thank you so much for listening.